All right, we're going to talk about water in this lecture, and water is very important to our life. Um, we take it for take it for granted. Sorry, that's what I'm trying to say. That we have clean drinking water that is readily available in many countries today, even today. And clean drinking water is not as readily available as we have it here. Um, so without clean drinking water, life becomes very difficult. So, we're going to talk about water in this lecture, and maybe you'll appreciate water more after this lecture. I hope so. So, water is different from chemicals, from other chemicals in several ways. First of all, density. So, remember, density is mass over volume, and what's unique about water is that solid water, so H2OS, is less dense than H2O than liquid water. So what does this mean for us? Well, that means when you drink ice water, where is the ice? Well, the ice will float. So these are your ice cubes and this is your liquid. So ice is less dense than, or sorry, not ice, water, which is a liquid. Um, so that's an important property of water. Other chemicals, often you'll find that other chemicals, the solid version is more dense. So if that were the case with water, then ice would sink. So um, this is very important for life on Earth because if ice was more dense, lakes would freeze from the bottom up and kill the plant and animal life. But because ice stays on the surface, life can survive beneath it. So that's a very important property of water that we often take for granted. The other unique property of water is freezing. Water expands upon freezing. So my brother-in-law, at one point he was drinking regular Coke, and he liked to drink his Coke cold. He did not like warm Coke, and he didn't like it on ice. He wanted it out of the can cold. So whenever he'd come over to my parents' house and he, he and my sister would have dinner with us, he would always insist on putting a Coke in the freezer. And inevitably, he would forget about it. And then what would happen? The Coke would explode. And that's because the majority of Coke is made up of water. And what happens when water freezes? It expands. And so this concept can also be applied to your pipes in the winter, your water pipes. If it gets too cold in your house, then the water will expand and they will, um, the water will freeze and expand, and then you'll have a huge mess on your hands. Um, so there are a lot of other things that I have written in the notes, about water expanding upon freezing. Um, so there are different ways that you can freeze water quickly. You can do things with a reduced pressure. But it's beyond the scope of this class. So two things so far. Density. Solid water is less dense than liquid water. Freezing. Water expands upon freezing. Heat capacity. Water has a high heat capacity. That means it's able to absorb a lot of energy before its temperature rises. Absorbs a lot of energy before temperature increases. So this is really important when you think about the whole Earth as a whole, because we have these large oceans, and they act as heat reservoirs. So they keep the climate relatively stable. We do not have extreme cold or extreme heat like other planets like Mars and Venus do, which don't have liquid water. So it's wonderful to have these large oceans of water that can absorb energy and keep our climate stable. Even though in Kansas sometimes it feels like our temperature it varies tremendously, but maybe that's because we don't have so much water around us. Um, okay, the last thing about water is that water has a high heat of vaporization. It takes a lot of energy to evaporate water. Um, high energy to evaporate water. And when I say evaporate, I'm talking about going from a liquid to a gas. So if you've ever placed rubbing alcohol on your skin, it gets cold. You know, like if you get a shot or you get blood taken, um, it starts to evaporate very quickly. But if you have water on your skin, it takes much longer for the water to evaporate. Think about when you get out of the shower. The water stays on your skin and you have to dry yourself off with a towel. Okay, so that brings us to the water cycle. So water cycles between the Earth's surface and the atmosphere. So if you think about the clouds and you have the sun, this is supposed to be a sun and these are clouds if you can't understand my drawing. So you have, this is the ocean and these are lakes and streams. So I'll put a lake. Okay, so water leaves oceans and lakes by the process of evaporation. So evaporation. You know what? I'm going to do this in a different color. Um, okay, so that's evaporation. You can see that very well. Okay, and then it returns to Earth by precipitation. So when you have like rain or snow, this would be precipitation. So this cycles back and forth, cycles back and forth. So the evaporation, water leaves oceans and lakes, and then water returns to the earth by rain, sleet, snow. So it can go back to the oceans and lakes, or precipitation can occur over land where the water may evaporate back into the atmosphere. It may filter into the ground, or it may become frozen in permanent snow or ice. So this water that returns to the earth by precipitation, whether it be rain, snow, or sleet, and it goes to the ground, it saturates the ground to a certain level called the water table. So water saturates the ground. A water-bearing soil layer is called an aquifer. So this is a water-bearing soil layer. So, the settlers that came to Kansas and Missouri, in order to get their water, they didn't just call Water One and say, "Hey, I just moved here. Can you get me set up with some water?" um, no, they would have to dig for a well, and it was pretty dangerous to dig for a well. They would dig and they would dig and they would dig, and I mean, it would get to the point where they couldn't stand up and dig anymore. They would be in the hole digging, and they would continue to dig, and they would continue to dig. And sometimes they would have to drill 100 feet to get to the aquifer. So that was where their water source was, this aquifer. So that was their water. They didn't have a stream or a river nearby. Um, and digging a well is kind of dangerous because there's natural gas trapped in some areas. And this methane, if you're down there digging, there's not going to be any oxygen down in this well, so you could die. So all of these things that we take for granted now, which not that long ago were difficult for our ancestors to get, it's pretty amazing when you think about it all. Okay, living in Kansas and Missouri, you find that as this water moves through the ground, the underground, this aquifers, it picks up these minerals. So most often, minerals that are picked up, it moves through underground, so water picks up sodium, potassium, calcium, and magnesium. So this has to do with the rock that it passes over. So the sedimentary rock or calcite. So what happens is that calcium and magnesium can precipitate out. That means that solids can form in the water. And so this buildup, this white buildup that we're all familiar with, is what is termed hard water. So we have a lot of calcium and magnesium deposits in our water. And this is why it's no fun to clean a shower door in Kansas. But you find different things that can clean this hard water. So the process of removing these ions is referred to as softening the water. So water softening. So this is removal of calcium and magnesium at the water plant. Okay. And my sister-in-law has a water softener, and whenever my husband and I would visit her, we would say, like, what is wrong with their water? Their water's all wrong. I feel all soapy after I take a shower because you're used to this hard water. But anyways, that's what hard water is. Calcium and magnesium dissolved in your water. Okay. So contamination. There are several types of contamination that can occur. Chemical contamination arises from chemicals being discharged into the water system. Some of the major contaminants are from nitrates. Remember, nitrate is NO3 minus. These come from fertilizer. So we like our lawns green, and when you get these little pellets put on your grass to make your grass grow and be healthy, that runs off into our water supply. So if the nitrates are ingested by humans, they can interfere with hemoglobin production. So this can cause blue baby syndrome. And one of the problems with nitrates is that they're very soluble. They dissolve in water easily. Unlike those hard ions that we were talking about previously, calcium and magnesium do not dissolve easily. That's why you see this buildup on your shower head and on your faucets. So the other thing, volatile organic chemicals, these come from cleaning liquids, gasoline, oils, paints. So cleaning liquids, oils, paints, gas station, uh, gasoline supply. And a problem with these is that a lot of these are suspected carcinogens, so they can cause cancer. And then to a smaller amount, metals such as lead, mercury, copper, and arsenic can be found in the water. Arsenic is AS. I wanted to make sure. Some of this is from natural sources, rocks and minerals, and some is from factory waste. So if you have high concentrations of these metals, they can interfere with physiological processes, and they often present as neurological problems. So that can be a big problem. Sources of chemical contamination in water can be agricultural runoff, so that's like fertilizers we were talking about. Industrial sources can be manufacturing, so factories, etc. Um, the other thing with industrial processes is they use a lot of water for cooling. That then they have these processes that are very hot. A lot of times it will be water cooled, so they will have water running around this, and then that water can get contaminated with those chemicals. Um, and, and this hot water disposal is a significant environmental problem. Dumping it directly into rivers and streams kills the plants and animals present. So, hot water waste kills plants and animals. Okay, household sources, fertilizers, pesticides, as well as improperly disposed of paint, solvents, sewage, etc. And then natural sources would be erosion and weathering of rocks that can release metal ions into the system. I'll put in here cleaners, paints, fertilizers, etc. Okay, so acid waters. When sulfur oxides or nitrogen oxides are combined with water, they produce acids. So SO3 plus water produces H2SO4, which is called sulfuric acid. When NO2 plus water, when that's combined, nitric acid is formed. So these sulfur oxides and nitrogen oxides are produced when coal or water or gasoline is burned. Produced by burning coal or gasoline. And what happens is, so you have this, let me see, you have this fire, right, that is fueled by, we'll say, gasoline. So then you have the SO3 and O2 being going up into the air, the atmosphere. So this is gas at this point. So it combines with the water that is coming down. That is coming down. And that's where you get your acid waters. So this mixes and you might get H2SO4 liquid coming down as raindrops. So now you have acid rain, which is not good. So this can dissolve rocks. Acid rain dissolves rocks and also affects living creatures. And then impacts soil as well. So it's a big issue. that you might not necessarily think of because you think, oh, well, this is just a gas that goes into the air. How is this going to impact water? Well, there's water coming down, there's water vapor everywhere that is in the air. Um, so it's there, and this reaction could always take place. Okay, so um, we are very fortunate to have access to clean drinking water. Um, this is one of the biggest innovations for humankind. Um, it it was not that long ago that people were dying because of their drinking water, and it still happens in a lot of countries. So we're very fortunate to have clean drinking water. So biological contamination can occur, and this is biological contamination of water, of course, can occur from bacteria and other microorganisms which enter the water system. When sewage was emptied into water sources just a century ago, severe epidemics of cholera, dysentery, and typhoid occurred. So, um, bacteria contaminates water, most often sewage, and then it causes cholera. Oops, I spelled it Cholera, dysentery, and typhoid. So if you think about going to drink water out in the nature, you wouldn't just go up to a pond and drink this water. You don't know what is in that water, right? Um, but it wasn't that long ago that the link between sewage contaminating your drinking water just wasn't well established. And so when it became clear that your wastewater had to be separated from your drinking water, that was a huge innovation. Huge. So, so very grateful for that every day. So another problem that can come up with biological contamination is biological oxygen demand, which is called BOD. So microorganisms that digest waste need oxygen to survive. So microorganisms that digest waste need oxygen to survive. Um, the amount of oxygen needed by a body of water depends on the number of microorganisms inhabiting it. The biological oxygen demand is a measure of how much oxygen is needed by microorganisms. So we were talking about chemical contamination of water. We're talking about these nitrates, fertilizers, phosphates that can contaminate water. This can impact the microorganisms that live in the water. So, so high fertilizer runoff, and this is in the form of nitrate or phosphate, is high food for microorganisms. If there's more food, you increase microorganisms, and then you decrease the number of and decrease the amount of oxygen present in water. Okay, which leads us to eutrophication. So that means not enough O2 present, microorganisms die. And then because these microorganisms, remember they can digest waste, so you decrease ability to digest waste in water. So then what happens? It just gets worse and worse. When not enough oxygen is present, anaerobic bacteria will begin to multiply. So they don't require oxygen. When these digest waste, they produce methane and hydrogen sulfide. So when no O2 present, anaerobic bacteria increase, which then increases CH4, H2S. So this is methane and hydrogen sulfide. Anytime you're dealing with sulfur, that is stinky. So basically, you increase the stink of your water, which is very unpleasant, right? You don't want to drink water that smells like rotten eggs. Um, and the other thing is it's very flammable, which is not ideal either for water. So, okay, so this brings us to water treatment, which is very important. I feel like I just keep emphasizing we're so fortunate to have water that is clean and has been treated. So in order to remove contamination from water and make it more drinkable, another word for drinkable is potable. So if you see trucks that drive around and they have non-potable water, that means you cannot drink that water. Um, so water treatment plants, wastewater treatment, they use several different processes. So dirt particles and bacteria can be removed by forming clumps, gelatinous clumps, to absorb the particles. So, and then filtering it. So, uh, dirt, bacteria removed uh, by filtration. Taste can be improved and odors removed by aeration. So, bubbling air through water um, increases taste, improves the taste, and decreases the smell. Chemical disinfection is usually carried out by adding chlorine to kill bacteria. Chlorine added to kill bacteria. And then fluoride is added to drinking water to reduce tooth decay. Added to reduce tooth decay. Okay, in many parts of the world, not in Kansas, right? Salt water is readily available. However, salt water is not drinkable. So fresh water can be obtained from salt water by two methods. So the two methods that can be used, distillation, salt water is heated, and gaseous water, which is pure water, is trapped and condensed. The salts and other impurities remain as solid waste and must be disposed of. This method requires energy to heat the water, usually by burning coal. So water is heated and boils. The boiled water goes to a gas, which is then converted back into liquid water, and this is drinkable. You don't want to drink that salt water. Um, so I'll say salt water here. Okay, so the reverse osmosis is a semi-permeable membrane. So if you think, oh, what is this fancy word she's saying? So a semi-permeable membrane would be like your contact lens. So it allows some stuff to transfer through, but not big particles. So it has very fine pores, which allow water molecules to pass, but not larger contaminants. So semi-permeable membrane allows water to pass, but not larger contaminants. So if salt water and fresh water are placed on two sides of a membrane, normally both sides end up equally salty. The fresh water moves over to dilute the salt water. However, in reverse osmosis, the process is forced to work in the reverse direction, so producing water from the salt water. This method also requires energy to pump the water through the semipermeable membrane. So both of these processes require energy. Um, all right, so the last part of our lecture is from wastewater to drinking water. So wastewater needs to be cleaned up before it can be returned to the environment. And this has not been around for that long. And very grateful for that. But so primary sewage treatment involves removal of solids and basic disinfection. So removal of solids, basic disinfection. Sewage is often held in settling ponds or screens where it is used to filter out larger solid materials. The sludge must be disposed of as solid waste. Sometimes it can be burned and the ash is disposed of. Bacteria decompose some of the organic material. Water is disinfected. So chlorine is added to kill the bacteria, and ozone kills bacteria as well. So disinfected, chlorine and ozone. So the secondary wastewater treatment involves removal of fine particles and small organic molecules. So aerobic bacteria are used to remove more organic material, just like they did in primary. Sewage is aerated. That's when oxygen is bubbled through. And then the sewage is passed through filters to remove fine particles of solid. So filters. And lastly, the tertiary wastewater treatment is sometimes needed. So this is charcoal filtration. Let's see, and if you have like a Brita water filter, those filters just contain a piece of charcoal. So you replace them, they're just absorbing particles and organic wastes. And then reverse osmosis forces the water through a fine mesh membrane to remove larger particles. So reverse osmosis. Okay, so this is why you have to pay wastewater treatment depending on where you live. This is a big deal, very important. And if you ever are paying your bills and thinking, gosh, I really wish I didn't have to pay this wastewater treatment bill, think differently of it now, okay? This is what prevents you from dying of dysentery or typhoid or cholera, which are very unpleasant deaths. Just severe diarrhea, just miserable. So we live in, much better times than our previous ancestors have. And water is very important to life. So hopefully you've learned something about water and think maybe a little bit differently about it. But it is a very unique chemical in so many ways, and we need to treat it with respect, right? So, um, if you've chosen this as one of your Unit 5 um, areas of study, right, obviously you're listening to this lecture, be sure that you choose one more. It can be air, energy, or polymers. It just needs to be one, so you can choose two of the four. And then when you go to take the exam, they will all be available. Um, and you don't get extra credit for taking several of the exams. You don't, if you take all four, you don't get extra credit. But you just take two, take those exams, and leave the other ones blank. When you take your exam, it's not going to give your score back immediately because I need to go through and figure out which student took air and water, which one took energy and polymers. You know, like each student's different, and I don't know which ones you're going to do ahead of time. So just be aware of that. But anyways, that finishes this lecture. Do the practice quizzes and homework assigned for this unit, and you can take your exam whenever you're ready. All right, until next time.